Hello everyone, I'm Sebastian Y and this is Managerial Economics. In this video we're going to talk about how to address the omitted variable problem using proxy variables and then wrap up our study of regression. In the previous video we talked about how to use controls, which is the simplest and most straightforward way to deal with the omitted variable problem. Simply take the variables that were causing a problem and put them into the regression. The problem is that a lot of times the controls that we want to use are not available. Sometimes this is because that variable cannot be measured or simply was not measured in the data collection. One solution to this is to use a proxy variable instead. We will still never be able to estimate the effect of the omitted variable on the dependent variable, but we will at least be able to get rid of bias that it is causing in a variable that we do care about. A good proxy needs to fulfill three criteria. Number one, the proxy is correlated with the omitted variable. This one is the most straightforward of the three requirements. If the proxy is going to stand in for the omitted variable, they had better be correlated in some way. If they're not related, we won't solve any problems. This correlation can be positive or negative. We typically think of proxies being positively correlated with the omitted variable, but it is completely possible to get a little bit clever with it and find one that is negatively correlated. Number two, if the omitted variable could have been in the regression, then there would be no endogeneity. This is less a requirement of the proxy itself than a requirement on the overall regression model. Number three, the part of the omitted variable unexplained by the proxy is uncorrelated with all explanatory variables, including the proxy itself. What this is saying is that there are essentially two parts to the omitted variable, the part that can be explained by the proxy and the part that can't. The problematic part of the omitted variable needs to be the part that's correlated with the proxy. If it's not, then the proxy has not fully fixed the problem. If these three requirements seemed a little bit confusing right now, we're going to illustrate each of them with an example. We're going to go back to our Mincer equation, wage equals beta naught plus beta 1 education plus epsilon. In the previous videos, we talked about the fact that ability is an omitted variable here because it's correlated with both education and wage. Unfortunately, ability is not something we can directly measure because it's more of an abstract idea. So we have no way of actually including it in the regression as a control. We'll need to find a proxy instead. A possible choice for a proxy would be an IQ test score. IQ is definitely an imperfect measure and a controversial one at times, but that is okay. It does not have to be exactly the same as ability, it just needs to be able to stand in for it. Suppose that the relationship between ability and IQ is given by the equation ability equals gamma naught plus gamma 1 times IQ plus epsilon A. Gamma naught and gamma 1 are just parameters, and I'm using a different Greek letter here to indicate they are not the same as the betas, but they function the same way as the betas do, but in the ability equation. Epsilon A is just the error term for this equation. I put the subscript A to differentiate it from the epsilon in the equation at the top. Requirement number one is simply that IQ and ability are correlated. As we mentioned before, IQ is not a perfect way to measure ability, but as long as gamma 1 is not 0, then we are okay. Could be positive, could be negative, doesn't matter. Here, it's probably going to be positive. Requirement number two is that had we been able to include the omitted variable in the regression, so we'd have beta 1 times education plus beta 2 times ability plus epsilon, that there would be no endogeneity in this equation. Essentially what this is saying is that the proxy is only going to get rid of endogeneity if there aren't also other problems with this regression. This is probably not true in this case. There's probably plenty more omitted variables here, including experience, which we talked about in the last video, but that's not really our focus here. We'll just assume that this is a good regression model. Our third requirement is that the portion of ability unexplained by IQ, that's this part right here, is uncorrelated with the rest of the variables. So we need epsilon A uncorrelated with IQ and education. Let's think about the portion of ability that is not related to IQ. We tend to think of IQ as kind of a book smarts measure, so the rest of ability could be something like physical ability or emotional intelligence, things like that. Are those correlated with education? Physical strength is probably not correlated with education. Emotional intelligence is less clear, but perhaps not. This is another case where we need to make the argument without having any data. So think through this logically. What are the other components of your omitted variable unexplained by your proxy, and do those have anything to do with your explanatory variable that you're trying to get an unbiased estimate of its effect? Back over here in Excel, we're going to add IQ to our Mincer equation. We'll run the regression with wage as our dependent variable. And then I'm going to add as our explanatory variables education, experience, which we added in the previous video, as well as IQ, which is going to be our proxy for ability. Let's take a look at these results and compare them with the last regression. In our last regression, we estimated the effect of education to be $76 per year of completed education, and the effect of experience as $17 per year of experience. Once we add in IQ, the education coefficient estimate has gone down. Since it used to be higher and now it's come down, we've removed a positive bias. This lines up with what we talked about earlier, that ability as an omitted variable causes a positive bias. And so if we add IQ, it should eliminate at least some of that bias. This causes the estimate to come down. Looking at what happened with experience, we have about $17 per year of experience, which is basically unchanged from what we had before. What this tells us is that there is very little correlation between IQ and experience, which I think makes sense. To wrap up our study of regression, let's return to our pirates example. We can represent the relationship between global temperature as temperature equals beta naught plus beta 1 times the number of pirates plus epsilon. From the graph, we can see that if we were to run this regression, we would get a negative relationship here for beta 1. The more pirates there are, the lower the temperature. The fewer pirates there are, the higher the temperature. In reality, the number of pirates probably has very little to do with the global temperature. However, there might be some omitted variables. The omitted variable I think is most responsible for this would be industrialization. Industrialization has led to more emissions, which has increased the global temperature. But what is the relationship between pirates and industrialization? One other thing that happened with industrialization is modernized navies, which were able to hunt down and get rid of pirates. So we have a negative relationship there. This gives us a negative bias. This resulted in it looking like there is a negative relationship between pirates and temperature that doesn't really exist. We can conclude from this that pirates are endogenous. To wrap things up, I want to mention that endogeneity is a serious problem when trying to establish causality in regressions. The vast majority of people in business do not understand this problem, and now you do. This is value you can bring to the table. We've only discussed 2 strategies for dealing with endogeneity. There are more, and if we were to spend the entire course on regression, we would get to those. But for now, this concludes our brief study of regression. This is just meant to get you started. In a way, I've taught you just enough econometrics to be dangerous, which is why we've spent this whole set of videos talking about the most important pitfall in regression analysis, the omitted variable problem. You also now have the tools to speak the language of data analysis, so whether or not you are actually going to use regressions in your career, you're probably going to have to communicate with people who do. Now you should be able to think a little bit more deeply about regression and be able to spot invalid causal interpretations due to omitted variables. That concludes our study of the omitted variable problem and regression as a whole. If you have any questions, feel free to let me know. Thanks for watching.